Now, in a previous example, I just did an example where I showed that if I integrate with respect to y and then to x, or then turn around and go x into y, it was the same result. And what I said was that we can do that. It's not a big deal. And actually, Fubini's theorem is what gives us that the ability to do that. Fubini's theorem says that if f is continuous on the rectangle R, so it's all x, y, such that x is from a to b and y is from c to d, then the double integral over the rectangle of f of x, y with respect to the area, we can represent this as the integral from a to b, c to d of f of x dy dx, but that's equal to, I'm going to change the order of integration, dx dy, but also with that, these bounds also changed. So I just switched both of these. Now, more generally, this is going to be true if we assume a couple things. Number one, the f is bounded on that rectangle R. Number two, f is discontinuous only on a finite number of smooth curves. And number three, the iterated integral exists. So if we can assume all of these, then we're in good shape. We can integrate in any order that we want. Now, if it's true that f of xy is greater than or equal to 0, then we can interpret this double integral over R of f xy dA as the volume that's supposed to be an M of a solid that lies above that rectangular region and under S, which is the surface, which is defined as, the S is defined as z equals f of xy. Now, just as a side note, just as kind of a reminder from back in Calc 1, we could accomplish the exact same thing if we could find the area of the cross-section of the solid. And that's a big if. But if we could find it, if it's some type of simple cross-section that we could find the area of the cross-section, then we could find the volume as simply being the integral from a to b of a of x dx, or the integral from c to d of a y dy. That's if we could find that represents the area as a function of x, the area as a function of y, depending if it's perpendicular to the x or the y axes. But if we could find that cross section, if you can, good deal. If not, then you definitely still have to do the iterated integral that we've been talking about here.